Today's lesson is continuation from partial fraction decomposition. We're going to deal with a special type when you have a repeated denominators. Let's look at example 1. Decompose the following fraction: 5x to the third power minus 9x squared plus 9x minus 12 over x to the fourth plus 3x squared. Once again, we're going to start with our factors. Factors of x to the fourth plus 3x squared is x squared times x squared plus 3. Again, notice that this x squared is repeated twice, x times x squared plus 3. So this is a special case when you have repeated denominators. Your x is getting repeated twice. The setup and the concept of solving partial fraction is exactly the same, but in the beginning you're going to add one more fraction since you have a repeated denominators. So let's start with writing the original equation: 5x to the third minus 9x squared plus 9x minus 12 over x to the fourth plus 3x squared. So there should be one fraction per every factor. So in this case, notice that we have three factors, so we should have three fractions. One is x, the other one is x squared, and the last one is x squared plus 3. Again, here's a special rule. If it's repeated, you're going to write the second one as you increase the exponent. So if it's repeated twice, you should write that once with the power of 1. The second time you write it, you have to write it as power of 2. So once again, this original equation is linear, so it has to be over a. Even though it's written as x squared, keep in mind this is a repeated denominator of x, so this is a linear function. The last fraction is quadratic, so you have to write it as linear, cx plus d. Now we're going to solve out the right side of the equation by finding the common denominator and simplifying. So 5x to the third on the left side minus 9x squared plus 9x minus 12 all over x to the fourth plus 3x squared. For the first fraction, common denominator will be x times x squared plus 3. That should get you x to the fourth plus 3x squared. The middle term is only requiring x squared plus 3. And the last fraction requires just x squared. And once again, now we have denominator to be the same, so we're going to compare the numerators. 5x to the third minus 9x squared plus 9x minus 12 should equal to ax to the third plus 3a x plus bx squared plus 3b and cx to the third plus dx squared. Now if you group them, 5x to the third minus 9x squared plus 9x minus 12, a plus c will be the coefficient of x to the third, b plus d will be the coefficient of x squared, plus 3ax plus 3b. So if you compare the coefficient, a plus c should equal to 5. b plus d should equal to negative 9. 3a should equal to 9. And 3b should equal to negative 12. Now if you calculate these values, your a will come out to be 3. b will equal to negative 4. c will equal to 2. And d will equal to negative 5. Now, all we have to do is go back and put your values in, and you will have your answer. So 3 over x plus negative 4 over x squared plus 2x minus 5 over x squared plus 3 is your answer. Now, second example. So now we have 8x to the third plus 13x over x squared plus 2 to the second power. So in this case, your factor is already kind of given to you. It's x squared plus 2 times x squared plus 2. You can see that x squared plus 2 is repeated twice. So you could start off with 8x to the third plus 13x over x squared plus 2 to the second power. This should equal to, once again, you should have two fractions because there are two factors. First one is x squared plus 2. And because it's the second one, you'll have a second power. You should have power of 2. Keep in mind, both of these equations are technically quadratic, even though the second one might look like x to the fourth power. So once again, linear because of x squared plus 2 is quadratic. So ax plus b. Once again, quadratic, so it has to be linear. Cx plus d. Now, let's rewrite the questions. 8x to the third plus 13x. X squared plus 2 to the second power. This should equal to, this side of the equation, you need to multiply by x squared plus 2. Then you will have two of these, x squared plus 2 times x squared plus 2. Right side of the equation, you don't have to multiply anything because this is already your common denominator. Or you could think it as you're multiplying by 1. Now, since the denominators are the same, now we're going to look at the numerators and also try to simplify this. So 8x to the third plus 13x will equal to ax to the third plus 2ax plus bx squared plus 2b plus cx plus d. Now let's try to group them by their variables. So 8x to the third plus 13x, 8 times x to the third plus bx squared. Now 2a plus c should be the coefficient of x, and 2b plus d should be the coefficient of a constant. Now comparing with the original equation we have, a should equal to 8, b should equal to 0 because there is no x squared, 2a plus c should equal to 13 since that's the coefficient of x, and 2b plus d should also equal to 0 because you don't have any constant. So looking at this, we could say that a will equal to 8, b will equal to 0, C will equal to negative 3 and D will equal to 0. So if you put them together, you should have 8x over x squared plus 2 plus negative 3x over x squared plus 2 to the second power as your answer. As conclusion, there should be one fraction for each power of your denominators. For example, your denominator in this case is x to the third times x minus 5. You have four powers in this case. You have x times x times x times x minus 5. So you should have four fractions. First fraction should be x. It's getting repeated second time, so the second one should be x to the second. Third one should be x to the third. Let's look at one more. X minus 3 squared times x squared minus 5 squared. So now, once again, we have 4, so you should have 4 fractions. First one, x minus 3 is getting repeated twice, so write the first one as a power of 1, second one as power of 2. Same concept as a second factor. X squared minus 5 squared is getting repeated twice, so write the first one as a power of 1, second one as power of 2. So what makes the repeating 0 different is the special rule for the factors is what's making the repeated denominators unique from the original partial fractions. Other than that, it's exactly the same ways to calculate the partial fraction.